All right. Good morning. Let's get going. So we've got 10-3 today. Happy Tuesday. Because I'm sure you're all going to celebrate right after school. 2:22 p.m. Yes. 2:22 at 2:22 on Tuesday.
You gotta set your clock to military time so it's like 22,
yeah.
22, 22.
Yeah, there you go. All right, we got a quiz review on Wednesday. That's tomorrow. And then quiz Thursday, and then we'll start a new section on Friday. All right, we're getting there. So you got some guided notes in front of you. We're going to talk about chords today. Shh, let's quiet down. So we named chords a couple sections ago. Chords are those segments that touch the circle twice. They don't have to be a diameter unless it goes through the center. Now, a couple of theorems that go along with chords. One is the theorem that talks about congruent chords.
Do you have a quiz this week?
Yes. In the same circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Now, notice the difference. We talked about this last week. When I say chords are congruent, we're talking about segments. Or if we're talking about arcs being congruent, okay, congruent arcs, same measure. So this arc AB is a length. Arc CD is a length. This is in two congruent circles, okay? So you're going to have to specify the difference between walking 100 degrees in one circle, not that impressive, it's small. Walking 100 degrees in a huge circle or in a huge lake, it's more impressive. We're talking about the same size circles in this case, so it's the same length for both. All right? So here you go. This is what you're looking for. What do you notice? Those double tick marks mean congruent. These circles, they're not just similar, they are congruent circles. They have the same radius. So if KJ is 80 degrees, then GF or FG, real easy, 80 degrees. 80 degrees. Now, do you notice it's not talking about the length of that chord? It's talking about the length of the measure of the arc, FG. See how it's an arc above it? That's actually what we're talking about. Okay. You would never say a segment is 80 degrees long. It doesn't make sense in this context. All right. Next. Oops, do we have another one there? Nope, that was it. All right. Next one, perpendicular chords. The diameter of a circle is perpendicular to a chord. Then it bisects the chord and its arc. So there's a couple things in this section you're just going to have to train your eyes to look for. Okay. If I see this, if I see a diameter is perpendicular to a chord, then what's the result? The diameter bisects the chord and its arc. So here's the chord. H must be the midpoint, right? Just cut that chord in half. And it created two congruent arcs. The green arcs are also congruent. And the converse of that is also true. Converse, remind yourself, converse means the hypothesis and conclusion have switched. So if you see those red segments congruent, or if you see those green arcs are congruent, then what kind of angle must be forming the diameter and the chord a right angle, correct? So that's the converse down here. If you see a pair of chords congruent, or I guess if a chord has congruent parts like that, or the arcs are congruent, then QS is the diameter, and it must hit it at a right angle. And remind yourself that is called a perpendicular bisector. Cuts the segment in half at a right angle. It's a lot easier to just do in practice. So here we go. First example. And I'm not so concerned about whether you're using the theorem or its converse. You just need to identify what's the process here. First of all, do we agree JL is called a diameter? Good. It goes through the center. It's chord. It goes through the center. It's called a diameter. And it hits HK at a right angle. So we could say those are congruent. Those parts are congruent, correct? Yeah. We can also say these arcs are congruent. So first part, what's HK? What's that segment? And this is not a diameter. This is just a chord. What's the length of HK? 14. Very good. HK is 14. And the measure of arc HK, well, we're going to have to do some math here. We should probably set those arcs equal. So 11x equals 70 plus x. Subtract x from both sides. We got 10x equals 70. Divide by 10. X equals 7. So what's the measure of arc HJ? H to J would be 77 degrees. What's the mark from J to K? 77 degrees. But they asked us for the whole thing, those combined, right? So what do you get? 77 plus 77 is 154 degrees. Now, we can't always go off of looks. But I would be a little concerned if I got more than 180 for that. Why?
Because it's not half.
Yeah, this is not a diameter. It doesn't go through the center. So do you agree this arc should be a little less than 180 degrees if it's drawn to scale? Correct? So I feel pretty good about the answer there. You try this one.
Are the vertical equal?
Vertical angles?
No, like when LK isn't like mirror to JH.
Arc LK
Yeah.
and arc JH?
Mm-hmm.
No, because that angle, N, the angle at N, angles at N, are not central angles. If N was at the center of the circle, then I would agree with you.
Okay, so half of this, I can't remember if half of this is what you.
All right, first of all, did everybody get 28 for KH? Everybody get 28. Awesome. These segments are congruent because we have a perpendicular angle at a diameter intersecting a chord. So these arcs are congruent. We're going to set those equal. 2x minus 8 equals 127 minus x. Add x, you get 3x. Add 8, we get 135. Let's see, what would that be?
45.
Thank you. Now, when we go to plug these in, we got 45 times 2, 90, minus 8. Did you get 82 degrees here? What'd you get here?
82.
But, so this arc's 82, this arc's 82. Be careful. They asked us for arc H, watch up here, H, L, K. Did you notice that was a major arc that was everything in the circle except for the green arcs combined? So what are the green arcs combined? 164?
Yeah.
Did you do, to get HLK, did you get 360 minus 164? Well, 360 minus 160 would be 200 minus 196, right? 196 degrees. $196. Did you get that, or was it tricky? Was it tricky? All right. Next one, it's a very specific theorem. Equidistant chords. All right. This one's just, if you watch it, I think it'll be good. I'll give you time to write it down. In the same circle or in congruent circles, two chords are congruent if and only if they are equidistant from the center. So watch up here for just a second, okay? Do you agree we don't know if CD and AB are congruent? Chords do not always have to be congruent. Here's what they're telling you. If they are the same distance from the center, so if this little segment and that little segment are congruent, then the blue chords are the same length. If those little green segments are not congruent, they're not the same length. So here's what we're told. AB is congruent to CD if and only if EF equals EG. All right, go ahead and write that down. So the pictures on these look kind of confusing. They look pretty busy, but they're not that bad. If you know what you're looking for. Do you guys remember what the if and only if means? I'll be really impressed if you remember exactly what its name is. Like, we learned it way back in chapter 2. Tally.
The IFF.
Yeah, yep, good. We had a special symbol, IFF, or a double arrow, I think. Did we use that one?
No.
There's a couple symbols. I don't know if I used all of them or not. IFF, you're like, oh, you misspelled if. Kind of. Or that's another way to write if and only if. Do you remember the converse, inverse, contrapositive?
Oh, yeah.
So like the P implies Q. This is P if and only if Q. Okay. So like if you clean your room, then you can go to the movies. If you go to the movies, then you must have cleaned your room. That's like a biconditional, like it works both ways. So biconditional is the word I was looking for. I don't know if I ever named it that or not, but biconditional works both ways. That's an if and only if. Every definition that you've ever learned that's true is a biconditional. All right. Definitions have to be able to work both ways. So what does that mean? Watch up here. If the blue chords are congruent, then they're the same distance from the center. And if they're the same distance from the center, then they must be congruent. So either way you're showing it, the other is true. So here we go. Let's see which one this is. QR equals ST, and those are both 16. Oh, look. Two chords are congruent. Conclusion. They must be the same distance from the center, good, from the center. So 2x and 5x minus 9 must be equal. 2x equals 5x minus 9. So 3x equals 9. So x equals 3. Find the radius of circle C. That's another level, right? I mean, we solve for x. We're good for there. Take a minute, talk to your table partners or to yourself if you're that kind of person. Try to figure out how we're going to find the radius of circle C. I'll give you a hint. I see some right angles in this picture. Am I right?
Yes.
Oh, I got a joke for you. It was on Friday. It was on the calendar. I really wish you guys could have heard it, so I saved it for you. How do you weigh millennials? How do you weigh millennials? Millennials in Instagrams. That's pretty good, is it? Come on, for a calendar of bad jokes, that's a pretty good one. Alana, not funny? Instagrams. I saved it for nothing.
Okay. No, that was very good.
Any ideas? Could someone name a radius up here for me? Huh? WC is a radius. Very good.
Oh.
CX is a radius.
So W.
Is QC a radius?
No. Wait,
Yeah,
yes.
could be.
Okay, well, it wasn't there.
Is CT a radius?
Yes.
Is CR a radius?
Yes.
I don't care which one you draw in. Draw in one of them. Now, because I don't want to confuse you with the picture. I'll just draw one of them in. Okay? And I'm going to highlight it so we can all look at the same triangle. Ready? U, C, Q. That's just the one I picked. It doesn't matter. Can we solve for, what are we trying to find? The radius. Can we find CQ?
Yeah.
All right. Well, if X is 3, what's CU? 2 times 3. 6. So this side is 6. What is QU? 8. How do I know? Oh, look. This chord got bisected because the diameter hit it at a right angle. Agree? That theorem we just learned? So we have 8. We have 6. Oh, look, we have a right triangle. We're looking for the hypotenuse. 6 squared plus 8 squared equals QC squared. 36 and 64. A perfect, beautiful 100. Square root both sides. We get a positive. Ooh, I even mentioned this last week. We get a positive and a negative 10, right? But it doesn't make sense here because that is a radius. It needs to be positive. So just positive 10. So what is the radius? 10. Beautiful. Now, could I have used SC. Yeah, what would I do? Plug in 3 for x. 5 times 3 minus, no. Okay, now be careful. That 5x minus 9 goes with, do you guys see it goes with CV? Okay, it's kind of confusing in the picture because it's drawn inside of the triangle I just drew. That was this length, right? 15 minus 9, 6, 8, and then you'd have the same calculations. You'd have 6 squared plus 8 squared equals the hypotenuse squared. You get 10. Does that make sense now?
Yeah.
All right. Try one similar. Try one similar. And if you can get it right, I'll give you 16 minutes to start your homework.
Oh.
Just draw it.
We're just gonna write it down.
Okay.
My favorite.
Come on, people. TikTok.
I can draw this.
I can draw.
Come on, guys. You need to be well-rounded.
That was really funny.
You have a little bottle cap in your pocket to trace
You
it
have
out.
no excuse.
Yeah, so just pretend like you're looking at people sideways.
Yeah. It's just
I know. That's messed up for like shit. That is disgusting.
You don't like any of this stuff. That's a really serious one.
doesn't look too triangle.
Get it, Ryan? What? No. Ryan?
Who's
I started my circle and I got distracted.
This is easy.
Ouch.
Is it?
Yeah.
Yeah, it's good enough.
I'm like, I know how to do it, I just don't know how to do it right.
It was like an old. You can't do too hard on yourself, man. Since you're now considered. Okay. What do you think, Ryan? I was like, or if you get negative.
If you act free again. Oh.
Pretending that I know.
You don't know what you're doing, do you?
What?
You don't know what you're doing.
shaking her head?
What?
Me?
I know what you
It's a good one.
Okay.
You guys won't appreciate it though.
Let's hear it.
How does Darth Vader like his toast? On the dark side.
I think I'm gonna
I think I got that.
Okay.
The joke?
No.
Yeah.
No, I don't get
It's not bad.
It's mine. It's my calculator. I got the handshake I think you should go up on the board and explain it. 'Cause I'm not really getting it.
Yeah, you should.
All right. Now we would view this one as like the converse of the theorem we learned. Oh look, this chord and this chord are the same distance from the center. They must be congruent, right? So we got the red chord, we got the blue chord. Now CD is 5x plus 7. I drew it in blue, but whatever. And AB is 7x minus 3. We're going to set them equal. Did you get 2x equals 10? So x equals 5. Yes? All right. So CD is 5 times 5 plus 7. What's CD? The whole length of CD. 32. But we know because that segment, EQ, is perpendicular to the chord, it must also cut it in half. So this is 16 and this is 16, right? Now we're kind of setting ourselves up for the same thing we did in the last slide, to draw in some radius. It doesn't matter where you draw it, kind of. I mean, you need to draw it to one of those edges. I hope you know you can't draw it straight through that bisector, the midpoint there, right? It's not going to help us out. Right, McKenna? Yep. So we're going to draw it there. 12 squared plus 16 squared. And don't forget, that's always going to be the hypotenuse. The radius in this scenario is going to always be the hypotenuse. Equals EC squared. Yeah, let's see. 144 and 256. Is that a perfect 400? I think so. Huh? 400, yeah. And then, yep, once we square root it. EC is 20. So this radius is 20. And no matter where you draw it in the circle, the radius will be 20. Does that make sense? Homework for you. You got 15 minutes to work.
Oh, that's not working. That's so